Welcome to homework.
Okay, so we've got some mass spectrum questions. And essentially, we've got something that looks like this. Draw a little straighter. Okay, and the question is, what is the molecular ion peak, right? And so the molecular ion peak is going to be the heaviest peak that you have, right? So in this case, it's this peak at 114. But I would argue instead that what you really want to call your molecular ion peak is this one at 112, and we'll talk about why that is in a second. But for now, I would say this is your M plus peak. So your M peak. Now your base peak is going to be whatever your most abundant peak is. In this case, your base peak and your molecular ion peak are one and the same. So 112 is your base peak. Right? Oftentimes it'll be a peak over here, but in this case it's not. Okay, and the next question is, why do we observe a peak at 114? And the reason is that we have a molecule which involves chlorine. How do I know this? Because we have a 3-to-1 ratio between our molecular ion peak and a peak that is exactly 2 mass units heavier. And that's because you can have chlorine 35, which is in 75% abundance, okay, and chlorine 37, which is in 25% abundance, which means that 75% of your molecules have a chlorine that weighs 35 mass units, and 25% of them have a chlorine that weighs 37 mass units, which is why we have this 3-to-1 ratio. It's basically the ratio of 75 to 25. It's 3-to-1. Okay. So that also answers maybe the next question, right? The molecular formula of the compound is C6H5X. Identify X. X is chlorine, right? We have C6H5Cl. Okay, finally we've got to draw the chemical structure of the fragment represented by 77. Okay, so that's this peak. How do we do that? Well, we'll notice that there's a gap of 35 between 112 and 77. 112 minus 35 equals 77, which means that chlorine came off, right? Chlorine weighs 35 or 37 to a smaller extent, right? So for that reason, if we want to identify if we want to draw the chemical fragment represented by 77, it's going to be the C6H5. And what you're going to find is that C6H5, when you're missing a chlorine, is just going to be benzene. Without this chlorine here, right? So benzene altogether weighs 78. Benzene with a chlorine right here is going to weigh 112. And then benzene with that chlorine ripped off is going to weigh 77. Now, the one thing I will point out is that this isn't standard. There's not a standard definition for molecular ion peak. Some people would consider that when you have chlorine, this is the molecular ion peak. And some people say that when you have chlorine, it doesn't matter if you have chlorine or bromine or anything, it's always this highest mass peak. And so they would say that 114. So it depends on the definition you've been given in class, but your molecular ion peak equals 112 or or 114, depending on the definition you were given, right? I have no way of knowing what definition you've been given, but you will find both definitions online when it comes to determining the molecular ion peak when you have chlorine or bromine, which has a similar isotope peak. In the definition that I think is most common is that this is the molecular ion peak and this is your isotope peak. So, or that this is your M plus peak, and then the other peak would be your M plus 2 plus peak.